Next is OMA Lightweight M2M. And OMA Lightweight M2M, as we mentioned earlier, provides a middleware architecture for connecting M2M applications to M2M devices. So in Lightweight M2M, they call the middleware a server, but it functions as both a CoAP client and a server, as do most CoAP devices. And they call the sensor device a client, even though it functions as both CoAP client and server in some cases. So Lightweight M2M uses CoAP to provide a REST API between applications and the client, and it provides a number of interfaces that are helpful in overall managing M2M applications. The Bootstrap interface provides a way for a new client to bootstrap itself onto a network, find out what servers exist, and potentially get new firmware upgrades, and get new security key material in order to operate on the network. So the initial onboarding can be done through the Bootstrap interface. Then the registration interface is provided so that Lightweight M2M devices can upload their links using resource directory and RFC 6690 that we just talked about to inform the server and let any applications discover the resources of the Lightweight M2M devices. Then there's a management interface, which basically is the REST API that the applications, management applications, and data applications use to interact with the Lightweight M2M devices through the server. That uses the CoAP REST API. And then finally, there's a reporting interface, which is the asynchronous notification interface of CoAP, and that's used for Lightweight M2M devices to indicate changing data to applications that are connected to the server. Lightweight M2M also provides an object model, which is a way to encapsulate resources using the REST API. So within a Lightweight M2M client, which is the sensor device or actuator device, there are a number of objects, and each object contains a number of resources. And resources are the endpoints that can be read, write, and execute. And objects can have multiple instances. There can be multiple instances of an object, and there can be multiple instances of a particular resource as well. For example, well, here's a set of Lightweight M2M management objects. And what Lightweight M2M provides is some base objects that are used for managing devices. So there's a security object that's used to contain security key material, a server object that's used for the Lightweight M2M device to associate itself with a server. There's an access control object that provides an access control list on the device that can control which Lightweight M2M servers have access to which resources on the device, and a number of other management objects that provide firmware upgrade capability, connectivity monitoring, location information, and so on. An example of what's inside an object, here's the Lightweight M2M position object, and it has resources that represent latitude and longitude inside it, altitude, uncertainty, in other words, how good is the GPS signal that would lead you to determine the error bounds of the position, the velocity, which is available from some GPS interfaces as well, and a timestamp. So a management application wanting to know the position of the Lightweight M2M device would be able to read the position object and determine all of these things from it. The way Lightweight M2M works as an application server and proxy, shown in the next few slides, basically the Lightweight M2M server is shown in the middle, the middleware. Devices register, as we saw earlier, by posting links to their resources to the server, and then web applications discover those links by doing discover operations, basically HTTP GETs. So what we have in the server is essentially a soft endpoint that is a proxy representation of each hardware endpoint that's registered with the Lightweight M2M server. And the web application interacts with the devices through these soft endpoints. For example, when a web application does a GET, it does a GET to the endpoint on the server, which is a proxy. And the lightweight M2M server then does a GET to the device. The device returns a reply to the server caches it if appropriate, and then returns a reply back to the web app. This allows the web app to use HTTP protocol and the devices to connect to the server using CoAP protocol. Also, the asynchronous notification goes through the proxy in the server as well. So the device will send a notification to the soft endpoint, and the soft endpoint will send a notification to the web app. Lightweight M2M offers a few other convenience features for controlling things that CoAP allows. For example, the observed parameters provide a way for the application to control the way asynchronous notification works. And it does this through a set of write attributes that the application can write to the device to control its observation and its asynchronous notification. So briefly, PMIN and PMAX define the minimum and maximum observation period to provide a filtering to limit the frequency so you don't get too many notifications. Also to provide some minimum number of notifications in case nothing's changing. Every once in a while you can get a notification anyway. They provide a less than and greater than limit setting so that the notification can occur whenever the value goes above or below certain limits. And it can provide a step parameter that defines the minimum amount the resource value needs to change to create a notification. So for example, in a temperature sensor, you could say only notify changes greater than 1 degree. And observed parameters are used on a per resource basis. So if you have a number of objects and a number of resources in an endpoint, each one can be controlled separately. Also, lightweight M2M allows a bulk read. So if you have multiple instances of an object or an object with multiple resources, you can do a read from the top of the device tree, if you will, and get back values from all the devices in a single response. And this uses TLV. The example shown below is SenML, which is the JSON dialect. And lightweight M2M also provides discovery using the same RFC 6690 links. So sensors upload links and applications can discover using the discovery interface, lightweight M2M. And lightweight M2M also allows communication through NAT routers because the registration with the core resource directory needs to be updated regularly. That provides a way for a NAT network address translation tunnel to be kept open on a router between the device and the server, and provides a way for the device server to connect to the device back through the router. Lightweight M2M also supports endpoint sleeping, so the NAT tunnel could close and the device could go to sleep. Then when the device wants to wake up, it can either send a registration update back through the router to open the tunnel and start interaction again, or optionally, not shown here, but the lightweight M2M server can send an SMS message to the endpoint if the endpoint supports SMS, and wake up the endpoint using an SMS wake-up message. Okay.